Hey there! In this video, we'll talk about the entities in the ABP framework. More specifically, we'll be talking about the entities, aggregate routes, and value objects. Entities are one of the core concepts of the domain-driven design. Eric Evans describes the entity as an object that is not fundamentally defined by its attributes, but rather by a thread of continuity and identity. It's an identifiable piece of software that refers to individuals, organizations, systems, bits of data, or even system components that are considered significant in and of themselves. Now, as a software developer, I'm assuming that you already know what an entity is. Think about it this way. You want to create a bookstore application, for example. One of the first things you want to do is creating the book entity that's going to have the name of the book, the price of the book, and so on. In the ABP framework, the entities are derived from the entity class with the primary key type, which is good in this example. And there are some good practices to consider when working with the entities with the good key type, such as creating a constructor that gets the ID as a parameter and pastes it to the base class. And also creating a private or protected empty constructor that'll be used while your database provider reads your entity from the database on deserialization. And also not using the good.newGood method to set the ID. Use the iGood service instead, while passing the ID from the code that creates the entity. The iGood generator is optimized to generate sequential goods, which is critical for clustered indexes in relational databases. And this is another example of us using the book entity in an application service. The book app service injects the default repository for the book entity and uses its insert async method to insert a book to the database. Now, some entities may need to have composite keys instead of good, and in that case, you may derive your entity from the normal entity class, not the generic good thing. The aggregate route is a pattern in domain-driven design. A domain-driven design aggregate is a cluster of domain objects that can be treated as a single unit. A good example of it can be the order or its line items. And these will be separate objects, but it's useful to treat the order together with its line items as a single aggregate. The generic aggregate route class extends the generic entity class, so it also has the ID property by default. You don't have to use the aggregate route all the time, you can in fact just use the entity class, but if you wanted to implement the domain-driven design, you're gonna have to create aggregate route classes. And there are some best practices to consider when dealing with aggregate routes. An aggregate route is responsible to preserve its own integrity. And it's also true for all entities, but the aggregate route has responsibility for its sub-entities as well. So it must always be in a valid state, and it can be referenced by its ID. Do not reference it by its navigation property. It's treated as a single unit, it's retrieved and updated as a single unit, and it's generally considered as a transaction boundary. And finally, work with the sub-entities over the aggregate route. Do not modify them independently. Now we've got a pretty solid example about the aggregate route right here. Order is an aggregate route with the good type ID property. It has a collection of order line entities, and order line is another entity with a composite primary key, order ID and product ID. Now, this example may not implement all the best practices of an aggregate route, but it still follows some good practices. It has a public constructor that takes minimal requirements to construct an order instance, so it's not possible to create an order without an ID and reference number. And the protected or the private constructor is only necessary to deserialize the object while reading from a data source. The order line constructor is internal, so it is only allowed to be created by the domain layer. It's used inside of the order add product method. And the order add product method implements the business rule to add a product to an order. All properties have protected setters, and that's to prevent the entity from being arbitrarily changed from outside. For example, it would be dangerous to set the total item count without adding a new product to the order. Its value is maintained by the add product method. Now we've got several types of aggregate routes according to your needs. The aggregate route class itself implements the IHAS extra properties and the IHAS concurrency stamp interfaces, which brings two properties to the derived class. The IHAS extra properties interface makes the entity extensible, whereas the I has concurrency stamp adds a concurrency stamp property that is managed by the ABP framework to implement the optimistic concurrency. It's too much details for now, but in most cases, these features are needed for aggregate routes. However, if you don't need these features, you can always inherit from the basic aggregate route class. We've also have a few others: creation audited aggregate route, audited aggregate route, and full audited aggregate route. And each of these define properties according to the needs of your aggregate route entity. For example, the creation audited aggregate route implements the creation audited object, and that defines the creation time and the creator ID properties. And if you need these two properties, then you can derive from this aggregate route. The audited aggregate route implements the audited object, and the audited object is an auditing interface, which extends the creation audited object and the modification audited object. And that will define the creation time, creator ID, last modification time, and last modifier ID properties. And the full audited aggregate route implements the audited object and the deletion audited object interfaces. And the properties that will be defined are creation time, creator ID, last modification time, last modifier ID, is deleted, deletion ID, and deleter ID. And you can of course use it if you need it for your entity. And the third main part for us in this video is the value object. An object that represents a descriptive aspect of the domain with no conceptual identity is called a value object. Let me put this aside and ask you something. What's the difference between an entity and a value object? Entities are defined by ID. So if I give you two entities with the same value but different IDs, then for the system they are considered different entities. Value objects do not have IDs. So if I give you two value objects with the same value, then they are considered as equals. They are considered as the same in the system. Let me give you another example. Let's suppose that we change the price of the book. Does that mean it's a whole other new book? No, we've only changed the price, right? It's still got the same ID and it still has the same name. Nothing changed, only the price. That is not the case with value objects. For example, let's suppose that we have the address class as a value object. And we've got the country, the city, the town, floor number, building number, and door number, for example. If only one of these properties change, then we have a completely other object. We're not talking about IDs anymore. IDs do not matter in value objects. The most trivial and the tiniest change in the least significant property of a value object means that we have another completely different and unique value object. And the rest is simple. We've got an empty constructor, a normal constructor, and the getAtomicValues method to return the primitive values. That can later be checked by the valueEquals method. Alright, so let's go to the domain layer. Here is our customer folder, and here is our customer class, which is the aggregate route. Here are the properties, and this is the customer group ID. We have not created it yet, and we are referring to it by ID because it's the aggregate route, like we said. And here is the contact information class. Let's take a look at it. So right here, it's an entity itself. It's got its properties right here, and some validation as well, and some methods. And it's not the generic GUID thing. It's using the composite keys. And also our value object. It is right here. We've got the country, city, town, line 1 and line 2, the empty constructor, the constructor itself right here, and the getAtomicValues. Same thing, we've got the protected constructor right here and the public constructor. We've passed these values to these two methods so we can check for simple validation inside the domain layer. And as for the max name length and max surname length, they are in the domain shared assembly right here. In the customers folder, we made this one right here, in customer consts. It's better for them to be in the domain shared layer so that they can be seen by other layers as well. They don't have to be in the domain layer. And these are just checking if it's null or just empty space. And we've got another method right here that adds contact information, and we're using the contact information class. As you can see right here, we've also got its constructor. We've got the customer ID, name, and the contact information type. Let's take a look at this. It's also in the domain shared layer so it can be seen by other layers as well. It's just a simple enum with the phone, email, and other. And we're setting the name and setting the value right here. It's just checking for simple validation right here, and the max name length and the max value length are also in the domain shared layer. And this is just checking whether the name already exists or not. If it does exist, it'll throw this error. For example, the phone information is already registered. And if it doesn't exist, then it'll add it to the contact information. Let's close this and check out these methods. Got the customers folder right here, and we've got our unit tests. Fun fact, we've injected the iGUID generator right here so we can run our unit tests with actual GUIDs without needing a database. If we used string ID, we'd have to go back and forth to the database every time we used the ID. So it's better to use the GUID in this example. And the first unit test that we're going to run is just a simple create a valid customer. So we're creating a new customer instance right here, the GUID, the name, the surname, and we're also using the value object to add an address, right? You can take a look right here, the country, city, town, line 1 and line 2, right? So the country, city, town, line 1 and line 2. And here we are using the add contact information method that we've defined right here. So the name is phone number, the contact information type is phone, and here is the value, right? You can see right here, the value, the type, and the name. And then we return it. And next we are checking our validation, right? Because it cannot be null or empty. So we've got the first customer that we've created right here. The first name is empty and the last name is just last name, whatever, right? And the second one with the first name as my name and the last name is null. And right here we are checking that we've got a name exception for our name and the surname exception for our surname. And we'll see if it catches the error or not. You see, we are checking these validations. And for the next one, we are checking if the contact information is unique or not. So we're adding a contact information right here with the same name that we've used up there. See right here? So it's not going to be unique, it'll be repeated. And the contact information type is phone, and the value is from 0 to 9. So we're checking this validation right here. Since the name already exists, then it shall throw this error. We've called it phone number, so it's going to paste in the name phone number right here, and then information is already registered. And if the exception message is the same as this string, then it shall pass, and it should pass. And last but not least, the contact information name or value cannot be empty. And as you can see right here, we are just testing these two. Just making sure they're not null or just empty. And as you can see, the name in the first one is empty, and the value in the second one is empty. As you can see, the name exception right here, and the value exception right here, and it should pass as well. Let's run our tests and see. And they have all passed. This was one of the most important concepts of explaining the domain-driven design. Please make sure to read the documentation, especially the best practices part, since we haven't and will not be able to cover everything in one tutorial. Thank you for watching and see you next time.